In this video, let's have a look at question 1 on the 2022 paper, dealing in the discriminant, two values for which this has exactly one solution. B squared minus 4ac, if it only has one solution, has to be equal to 0 from your junior cert knowledge of quadratics. This double root is going to just touch at one point. So b squared is going to be m squared minus 4 by 3 by 3 will be equal to 0. So you're going to get m squared minus 36 equal to 0. M squared equals 36. So m is equal to plus or minus 6. Exactly one solution. So we have our two values for our one solution. Part B, explain why the following has no real solutions. There's two ways to do this. Really quick way, you could say when your knowledge of the discriminant, if it has no real solutions, b squared minus 4ac is going to be less than 0. But if you just take this here, there's an easy way to do it. 2x plus 3 to be squared, if we bring the 7 across, would be equal to minus 7. And a number squared cannot be equal to a number less than 0. Therefore, no real solutions if you just wanted to do it algebraically. Or you could multiply it out. 2x plus 3 to be squared. I think this is probably what most people will do. Plus 7 equals 0. 4x squared plus 6x twice plus 9 plus 7 equals 0. So 4x squared plus 12x plus 16, get your x, equals 0. Divide by 4 to get x squared plus 3x plus 4 is equal to 0. So b squared is going to be 9, just write it here, b squared minus 4ac is equal to 9, minus 4 by 1 by 4. So minus 9 minus 16 is minus 7, which is less than 0. Therefore, again, no real solutions. C part 1, show that x equals minus 1 is not a solution of this guy. Write down what you're doing. X equals minus 1. Therefore, 3 by minus 1 squared plus 2 by minus 1 plus 5, is this equal to 0? 3 by 1 minus 2 plus 5 equals 0. It's just substitution. That's going to give 8 minus 2, 6 is not equal to 0. Therefore, not a solution. I always say they'll never ask you to say or to prove negatives, but here we're asked to show something is not a solution. And now, to your horror, the remainder, when we were looking at box method the whole time, we can still do this with the box method, but there's a couple of different ways to do it. Let me approach it maybe just with factorization first. If we have to get 3x squared plus 2x plus 5 when it's divided by x plus 1, we'd have to have 3x by something. We started it our pretty much our normal way, and then to get 2x, we already have 3x here, so I'd have to have minus x, so this would be a minus 1. Now if I multiply this out, you'll get 3x squared. I'll just multiply that this way, 3x squared. Then we're going to get plus 3x minus x minus 1, which is 3x squared plus 2x, which is what we're looking for, but we have a minus 1, so we'd have to add 6 to get our plus 5. So does it look like our remainder is 6 here? Well, let's do it. Maybe this is the way we were taught in school. If you have your 3x squared inside here, your quadratic inside, 3x squared plus 2x plus 5, I will do the box method as well. Divide by x plus 1, we say x into 3x squared is 3x, put your answer on top, this crazy method I think. Then multiply 3x by x plus 1 to get 3x squared plus 3x. You might see this over here. Then we multiply by -1 or change the signs. This is why they've tried to get rid of this method. It doesn't really make much sense. 2x minus 3x is minus x, which you may also see over here. It's just a different arrangement of the same numbers. And then we say this x again into the minus x is -1. So the -1 goes on top, which then again does the same thing. -1 by x plus 1 is minus x minus 1. And again, we're going to have to change these signs to cancel the x's, a plus and a plus. I tell you to do it like this. So that will be here, the remainder 5 plus 1, which is 6 as well. Second way to get the remainder. And would the box method work? You may have not seen the box method, but we only need 2 by 2 when we've got a quadratic divided by a linear. X plus 1. And into it we're dividing when we 3x squared plus 2x plus 5. I'll write it again, 3x squared plus 2x plus 5. So the first term and the last term in here. Well, I'll leave the last term out for now, will I? Let me just see here. No, let me just see. I'm dividing x plus 1, so we're going to get 3x here. We're going to get 3x down the bottom. We want 2x, so I have to have a minus x. So I'd have to have a -1 on top. And if I'll put the first and last term in plus 5 now. This is not correct because the way we always check them, -1 by plus 1 is -1. But inside the box we have a plus 5. And the difference between these two numbers, the remainder, is equal to 6. Not a question they've asked before about the remainder, but you know, maths should be challenging.